The Extended Touch CNC Fabrication workshop took place at Kingston University's Kingston School of Art in London, gathering postgraduate architecture students for an intensive exploration of digital material practice. The day opened with a lecture that situated computer numerical control, also referred to as CNC, within contemporary architectural and sculptural discourse, tracing its evolution and emphasizing its capacity for rapid, high-fidelity production. These two case studies were explained in great detail. On the left, the Sanrain rooms by Tonkin Lu, where CNC fabrication was used to cut plywood sheets. This developed into a bespoke experimental timber roof application on housing renovation project in London, and on the right is Blocked by Hour, which is a prototype where CNC was used to cut panels that were assembled to plywood blocks that were then assembled to create different structures throughout London. So these two case studies were used to explain how computer numerical control can be and will be continue to use in architectural practice. Students examined canonical and contemporary reliefs by architects, designers, and artists. Drawing on these precedents, they produced preliminary plan and section sketches for an architectural relief, consulting reference books and digital catalogs provided in the studio. Case studies of Isamu Noguchi's landscape sculptures, the modular geometries of the Zero movement, Danny Caravan's environmental installation, and Ricardo Bofill's monumental formalism demonstrated how scale, surface, articulation, and materiality translate into CNC milled artifacts. In the following footage, you can see students looking at precedents and the initial hand sketching exercise, highlighting the iterative dialogue between drawing and designing. Revisiting the workshop proposal theme, exemplary project from previous cohorts illustrated how CNC can function not only as a subtractive production tool, but also as a critical instrument for sculptural thinking. Here, Joshua designed a bespoke column in a gallery made from interlocking blocks. We address technical parameters, including size of drill bits, step over, spindle speeds, and toolpath strategies, mapping the entire workflow from digital model to finished object. A guided visit to the digital fabrication laboratory followed. Staff introduced the students to CNC machine, explained work holding and safety, and offered advice on preparing 3D models. Viewers observe live demonstrations of the machines in operation, emphasizing the translation of virtual geometry into material form.
Degree V-tip cutter. Can you see that it's actually got quite a sharp point to it, and the walls of that cutter come in, and as it's rotating, we'll cut. Actually, that was a 45. Anyway, it's a 60 degree, and you can also see this one would be a 45. Okay, so they're V-tip cutters, and they can be used to put chamfers on edges. They can be used to pick up line for engraving, and you can get much smaller versions of this. It will actually pick up the tool in a tool cone using air suction, and that's a way of using multiple tools on a program without me having to change them over and over again. As you can see,
Students refined their Rhino models with reference to cutter diameters, axis clearance, and minimum feature size, internalizing the relationship between the design intent and fabrication logic. Detail handling of bow nose, flat end, and taper cutters enabled participants to evaluate distinct surface textures and guide aesthetic choice. Close-up of the bits and sample mute swatches underline the tactile differences achieved through tool selection. Here, there are the 4 different stages of the CNC process. From designing to preparing CNC toolpaths in RhinoCam, CNC milling, which includes milling the design using the toolpaths in the CNC machine, and then casting and finishing, which is casting the plaster and sanding to remove imperfections, which I will talk about in further detail shortly.
And it's a soft rolling hill. Okay? Soft rolling hills, we want to cut that with a wide cutter. Something like this. It's going to be probably twice as fast as something like this. Half the size, and thus it's what is called a step over. So when you're running a cutter over an object, you've got to imagine this cutter's got to be able to cut.
Advanced machine configurations such as automatic tool changers and vacuum tables were examined, showing how automation saves time without compromising precision, and thereby supports the proposal argument for efficiency. We focused on 2 CNC machines that were available in Kingston University. On the left, Roland MDX with varied dimensions, but this is one of them. It's easy to operate and you can use it to mill low density materials. And on the right, the larger CNC machine, which measures almost 2.5 meters by 1.5 meters, which is used for advanced operation, high density materials milling.
There's 2 types of CNC cutting that we offer here. 3D shaping, which is what I believe you're going to concentrate on. Now, 3D shaping requires the cutter to move over a 3-dimensional model. Okay? So that's going to involve a 3-dimensional file showing all the different points in space. Right? You can get a 2.5D, say, outcome from the CNC router using 2-dimensional vectors. Now, what that is if you can communicate what's going on from a plan view, essentially they are then boundaries. These are vectors that are boundaries, and we can interpret those boundaries and cut inside, outside, or on if they're a continuous loop. If it's a singular line, you can only ever cut on the centre of that line. But I don't want to go too much into that. It's a simpler, quicker way of getting a 3-dimensional form. But I don't think that's the remit of what you're doing. You're going to need.
The session with the Digital Fabrication Laboratory concluded with a comparison between flat ends bits and bow nose cutters for smooth terrain. Step-over percentages were explored and how they affect surface resolution. Surface finish comparison side-by-side footage of roughing and finishing passes illustrated how incremental step-over adjustments can refine the surface of the models. Armed with this knowledge, student teams presented evolving designs to fabrication staff, receiving feedback on design optimization.
Your model to have a look at what it's not getting to, because your surface is coming up and away, which means the radius it's leaving is going to be bigger than if it was coming away flat. At the bottom, you can still see there's a radius. Yeah?
We then moved to the plaster workshop, where students were introduced to basic model making and plaster casting as complementary analog processes. The lecturer quantified material requirements and demonstrated correct mixing ratios, emphasizing gradual plaster disposition and vibration to minimize entrapped air. In a following video, the lecturer provided a step-by-step guide showing how to cast plaster. These different stages of how making a relief illustrated the process of casting and finishing a plaster cast model, starting from making a vacuum form out of the CNC mold, continuing with a cast plaster into the mold, then sanding the final piece and applying any additional coatings such as paint, varnish, if you're using wood.
Share it, I reckon. Most people can get, I don't know, maybe about 2 or 3 out of 5 kilograms.
Okay.
Yeah, rough around that. I'm just estimating, yeah, but I know you can definitely share it. So what I do, you order it, and then I'll do the bags for you, and then I give you the bags. So when you're doing molds like this, it's always a good idea. Yeah, when you're doing molds like this, I tend to go for something smaller. Don't go for the big bowls, but when I'm here, I'm going to go through stuff with you anyway. So you can buy the plaster from me and stuff like that. So the main thing about the plastering, I know it's a bit messy at the moment, but it won't be like this later. But the main thing is, if you have any, with these bowls, the reason why I like these bowls, sometimes you can leave the plaster in there and then we scrunch it later and then put it in the bin. But what I like about these bowls is that they're quite flexible. So when you do the mix, I tend to hold them like this and then pour.
The cohort proceeded to the vacuum form workshop where thermal forming was presented as a method for producing lightweight, reusable negative molds with a superior surface finish. A live demonstration illustrated clamp frame operation, dwell time, sag control, and vacuum pressure, translating thermoplastic behavior into actionable fabrication skills. In the following video, the lecturer provided a step-by-step guide on how to use a vacuum form machine. In this photograph, I show how a plaster cast can be poured into a vacuum form and then left to dry for at least 24 hours.
Yeah, if it's overlapping, you're not going to get proper suction. The whole point of this thing here is you've got little vents here, and it's sucking the air to create the form. Yeah. So you put this piece, so this is PVC, so when you're buying this stuff it's called PVC. You place it in here. Usually when you do this it's all pre-cut for you from Stuart, yeah? Then you place this piece down and then you lock it. Yeah? And then what we do, we bring this over. I'm going to repeat this thing again, you know, so I'm going to repeat it twice. When I do the demonstration. So you pull this over, you put this to about 30, you stay underneath here, you keep an eye on it, this will kind of start waving and bubbling up, and then it starts kind of like a nice bow, kind of like a kind of dip shape. And then when you see that, you flick this, so on this side here, you flick this out, and then you jam it, yeah? And then you flick that, and it does the suction, yeah? But I will show you guys again this, yeah? Because I don't know. So anyway, so I'll show you example. So give it at least 8 minutes to warm up with this. So if we go over here, there's a nice border around it. You don't want it to be too. But no, I need to get a suction. I need to get really good suction. Place this down. Okay, so you know something's wrong here. I've pushed it down here too much. So I want this to be dead on the centre, so I can get some suction. This, and lock it like that. Yeah. Right, so there's kind of a temperature thing here. It varies throughout the day. If you guys have been on this for a long time, this is going to get hotter and hotter and hotter, so the timing gets a bit shorter and shorter, slightly shorter, yeah? But I'm just going to go by 30. 30 seconds. So I'm going to put this on here, go on 30 seconds, but I'm still looking at it. So if you guys look down, so you can see that, you see it's kind of bubbling. Doing that motion. You don't want to burn this. It's not good for you, yeah? So you see it's kind of bubbling. And it gets to the point, you see these lines? So it gets to the point where you start seeing it get a bit smoother. So I'm keeping an eye on this, but I'm still looking at this. So look at this is not good, it's all raw, yeah? So I'm kind of looking more in the centre. So you still get a bit smoother here. So it's about this bit area that's a bit smoother, yeah? So I'm going to do it in a second. Right, so I pull this, and then stop. that's it. That means I bend that. Yeah. So this, and then, yeah. So I'll go through that motion in a minute.
And is there like how long do you have to keep it? How long do you have to keep the suction on?
It's done. You see it, just go. You sort of,
Yeah.
once it's done that, right? That's enough. And that's it. And because she's got the contour shapes on this one here, you can see how it vacuums neat, very neat. So with that, to release it, we pull this out. Most we're not supposed to do it like that.
Back in the studio, we broadcast reflecting on plaster's textile texture and the patience required for successful demolding. In the following clip, the sequence from lining the mold to the first touch of the hardened relief is showed. In these photographs, I demonstrate how refined and smooth you can achieve models can. How refined and smooth the texture of the models can get when you use vacuum form molding. So when you cast plaster into vacuum form and then release it, you can achieve very, very fine finish.
I'm sprinkling the plaster, but I'm going in a circular motion. So you just keep on going in a circular motion. And people always keep saying to people, how do you know? The plaster's going to tell me. Yeah? So you keep on doing it, and it gets to the point where, at the moment, the plaster is really absorbing the water, but it gets to the point where it starts to slow down. So I'll just put that layer there. In a minute, and I'll ask you guys to come over to have a look when I get the island. So it gets to a point where it's slowly absorbing the water. And that's giving me a hint, yeah, a visual hint. Let me say that again, yeah? Visual hint, yeah? So I continue doing it. And I'll get to a point when I get the island. When I get the island, I'll tell you guys to have a look at it. So you keep on doing it, you keep on doing it in a circular motion. You hear it go? That's giving me hints as well. I'm feeding it.
We also demonstrated how low temperature oven ensures best practice for water evacuation and structural stability after releasing the relief from the molds. These examples by Dongyi and Lee show the intricacy of the geometry you can achieve with making molds in CNC fabrication, but it is very important to ensure that you practice you employ best practice principles when you dry your plaster casts.
To do this, I don't know why they do that. All you need is one hand. It's always a good idea to have one hand. You might get some plaster in your eye, you need to get it out, or you need to maybe grab something you want it clean. So always have a spare hand that's clean. And just keep on mixing it. Yeah. The problem with the plaster sometimes as well, this batch, it's got plus on it. It's supposed to. They claim that it's supposed to be, each batch is supposed to be the same, but I think sometimes temperatures, like if it's a hot day, it has influence on the plaster as well. Yeah. So I don't know. Sometimes we use plaster and I do a demonstration like this, and it takes forever mixing it. And I'm thinking, what's wrong with it? And then there's days I'm doing it, it's really quick, you know. So today it's actually behaving itself.
Exemplars from previous cohorts illustrate the strategies for releasing complex undercuts and inspired experimentation with pigmented plaster and post-milling chiseling. So very similar to the previous example, this reliefs and tiles by Beatrix show the intricacy and the quite mesmerizing quality of light and shadow that you can achieve with plaster casts that are poured into molds made by CNC machines.
2, 3, 4 little bubbles.
Yeah.
I don't think that's going to be, because I took my time mixing it.
Yeah.
And if I take my time a little bit more, and I remember I banged it as well, so I added the bubbles into it. But I mean, let's try it high. But sometimes I don't want things splashing. Then again, you got a point. But then again, that's the last of the plaster. So with the amount I had, you only could get one. Yeah. So maybe with me, I would mostly just use a little bit less than what I did. Because remember, I had it about here. Yeah. So
With the technical visits complete, I conducted individual tutorials to interrogate each student's conceptual narrative, contextual references, and planned fabrication sequence, ensuring alignment between research questions and material exploration. These tutorials address tool access and deep reliefs, the cost of long finishing passes, and strategies for minimizing waste. A collective pin-up concluded the studio component. Students articulate the intellectual trajectory of their projects, peer-reviewed workflows, and synthesized digital and manual techniques into coherent design propositions. We close with a roundtable discussion on hybrid making. By juxtaposing algorithmic precision with the contingency of handcraft, participants recognize recurring themes such as tactility, landscape abstraction, and serial modularity that may inform future practice. These two photos show moments that students particularly enjoyed visiting at the plaster workshop on the left and the CNC department on the right. The workshop fulfilled its proposal by establishing CNC fabrication as both a practical technique and speculative design instrument. Participants advanced from sketches to milled molds and plaster reliefs, experienced the complete digital to material chain. Technical tuition was paired with critical reflection so that the competence and concept matured together. Students now possess a clear grasp of tool selection, workflow planning, and material stewardship, and crucially, a framework for integrating CNC processes responsibly into future architectural and artistic practice. Extended Touch affirms that automation can amplify rather than diminish the tactility of making. Thank you.